Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 6th, 2025. So, just yesterday. This paper argues that the current model for big AI conferences is broken and backs it up with some pretty stark data. For instance, travel for a single conference like NEUR IPS 2024 created more carbon emissions than its entire host city, Vancouver, on a typical day. The paper is titled, Position: The Current AI Conference Model is Unsustainable. Diagnosing the Crisis of Centralized AI Conference. And it doesn't just point out the problems, it proposes a completely new way of organizing these events. The authors identify a crisis across 4 fronts, including unsustainable publication pressure, serious environmental impact, a negative toll on researchers' mental health, and simple logistical bottlenecks where conferences are just getting too big. Alright, so this table really breaks down those challenges in more detail. It lays out the key finding for each problem. For instance, that the average researcher now publishes over 4.5 papers a year. The challenge column then describes the negative impact, like hypercompetition. And on the right, it maps these to the proposed solution, the community-federated conference model. This model suggests things like smaller, regional hubs to cut down on travel, and rolling submission cycles to ease the constant deadline pressure. Building on that point about publication pressure, this chart shows it visually. While other fields like theory and systems show fairly stable growth, the line for AI is a different story. You can see it here in red. It's just an exponential explosion. This trend is projected to result in over 65,000 annual publications by 2030. That sheer volume is what's driving so much of the strain on the peer review system and the community. So where are all these papers coming from? Well, this chart plots what the authors call effective faculties, which is a way of counting researchers that adjusts for people who work in more than one area. And you can see that the number of AI faculty, shown here in red, has nearly doubled over the past decade. In contrast, other computer science fields like systems and theory have stayed much more stable. The paper suggests this could even be siphoning talent away from other important areas of research. And all of that growth in researchers directly translates into bigger conferences and a much bigger environmental impact. This chart breaks down the carbon emissions for just one major conference, ICML, from 2019 to 2025. What's immediately obvious is that air travel, shown here in purple, completely dominates the total emissions. In fact, the total carbon footprint more than tripled in this period, underscoring just how unsustainable these massive, centralized events have become. And it's not just the environmental cost. There's a significant human toll as well. To get a sense of this, the authors created this sentence cloud from online discussions on Reddit. The larger the text, the more common the grievance. You can see huge phrases like, hurts to get LLM-generated reviews, and an 8,000-person mega club. Other complaints mention how it's hard to talk to people at poster sessions. This really paints a picture of a community feeling overwhelmed, anxious, and disconnected, which is the exact opposite of what a conference should be. And this brings us to the logistical breaking point. This chart tracks in-person attendance at NeurIPS, and you can see the number of attendees has just exploded, growing by over 335% to nearly 17,000 people. The attendance is now pushing right up against the venue's maximum capacity, which is this red dashed line here at 18,000. This physical limit is what forces organizers to use lotteries for tickets, which can exclude the very people, like students, who might benefit most from being there. So, from scientific pressure to environmental costs and logistical strain, the evidence points to a system at its breaking point. The paper makes a compelling case that incremental fixes aren't enough, proposing a federated model instead. That's it for this episode.